This is another chemical reaction. Let's study the effect of change of temperature on this equilibrium. Is it going to shift to right or left if we add heat? First, do you notice that energy heat is on the left-hand side? It's on reactant side. And we said, whatever is on the left, which are reactant, are always consumed in a chemical reaction. So can I call this reaction a heat-consuming reaction? So what happens if I add heat to an equilibrium reaction of this type? So I'm adding heat. Equilibrium is going to shift to a direction to do the opposite. That means consuming heat. That means decreasing the heat. Which direction would it shift? Obviously, it has to consume heat. It has to go forward. It makes more product. So reaction goes forward. Which means more of CaO and CO2. Do I make sense? Any questions? Guys, let's do another thing. What if I place this reaction, which is heat consuming, in an ice water mixture? That means I'm removing heat. If I remove heat, what is the opposite of removing heat? Making heat. Which direction this reaction is going to shift? To right or left to make heat, not consume heat. Do you see how the reaction is reversed? It produces heat and calcium carbonate. So if I remove heat from this reaction, which is heat consuming, it will try to make heat. As a result, it goes back, produces heat. The reaction is going to be reversed. So far we have learned there are two things we can do to shift an equilibrium toward direction that we need. One was changing the concentrations of reactants. The second one is changing the temperature of reaction mixture. The next, well, let me summarize, and then I go to another factor that we can shift an equilibrium reaction. So that's what we have said. If you want to change the concentration, you add more reactant. The equilibrium is going to go to forward to consume reactant that you added. If we remove reactant, reaction is going to make reactant by going to reverse. If you add product, reaction would like to consume product, so it must be reversed towards reactant. And if you remove product, the opposite of removing product is making more product, so reaction goes forward to make more product. And if we raise the temperature, the reaction is a reaction which is heat consuming, goes forward to reduce the heat. And if we lower the temperature of an endothermic reaction, is going to reverse to make more heat. And if the reaction is exothermic, increasing the temperature is going to reverse the reaction. And cooling off the reaction mixture by lowering the temperature, reaction goes forward. You don't have to memorize this table. Why? Because I just told you, use the reverse psychology, guys. Just tell yourself that if I make any changes, whether concentration or temperature, the equilibrium is going to shift in a direction to counteract that change. Then you can predict the direction of the shift of equilibrium. So, so guys, let's see if you can predict these changes. What is direction of shift of this equilibrium if we make changes of A through D? I would like to see who is the first who gets it. Raise your hand so I know you got it. Okay, Ainsley computer. That's Carl. Good job, Carl. Right?
No, I'm Anna's MacBook Pro.
So who is Ainsley computer? Ainsley.
Jennifer.
Ah, hi, Jennifer. Ainsley. Thank you. Good job, Jennifer. So guys, do these make sense? If in A, I am adding an O, I'm increasing concentration of product, the opposite of it is decreasing concentration of product. So reaction goes to reverse. It makes more reactant. If I am adding N2, equilibrium is going to shift in direction to consume N2. Can I say going from left to right consumes N2 and make more NO? So reaction is going to shift toward right, toward product. What if raising the temperature, do you see this reaction is heat consuming? I am raising the temperature, I'm applying heat. What is opposite of applying heat? Consuming heat. The way reaction can shift is go from left to right, which is heat consuming, to make more NO. So reaction is going to go forward toward the product. And what if I remove oxygen? What is opposite of removing oxygen? Making oxygen. How could this reaction make oxygen to be reversed? That means NO should break down to O2 and N2. The reaction is going to be shifting towards reactant. That means reaction is reversed. Any questions? Any questions? Okay.